For problems 20 through 31, we're just graphing linear inequalities. We like our linear inequalities to be in slope-intercept form. Number 21 is already in slope-intercept form. In this case, the slope is -3 and the y-intercept is 0. This gives us a graph like this. Since it's greater than, without a line underneath it, we get a dotted line. Because y is on the big side of the inequality, we shade above the line. Number 23 says y is less than or equal to -2x minus 3. Once again, it's already in y equals mx plus b form, so we can find our slope, our y-intercept, figure out if it's a dotted or a solid line, and then shade up or down. What about a problem like this? 2x minus 7y is less than or equal to 11. How do we graph it? Well, we want it to be in slope-intercept form, so we need to get the y alone. The first thing we should do is get rid of the x term. Remember, when we switch sides, we switch signs. So now we have a -2x on the right side. The -7y stays on the left, and the +11 stays on the right. Next, we need to get rid of the times -7. The opposite of multiplying by -7 is dividing by -7. So we are going to divide everything by -7. This will get our y alone on the left side. On the right side, we have a negative divided by a negative, which is a positive, and 2 divided by 7 is 2/7, and we can put the x to the side. +11 divided by -7 is just -11/7. From here, we can graph it and then figure out if it's solid or dotted line and shade up or down. Graphing with fractions is usually pretty messy, unless you make really huge graphs so you can have each notch be like 1/7 or something. But -11/7 is somewhere between -1 and -2. So I'll just say that that is it. I have a rise of 2 and a run of 7, which will put me somewhere around there. This will be a solid line, and we're going to want to shade down. So in summary, always get it into y equals mx plus b form first. Plot your points, figure out if your line will be solid or dotted, and then figure out if you need to shade up or down.